than you can imagine, right? Only with respect to passive house designing. So if you're designing your house with a passive approach, you're going to save much more energy without any additional cost. That is what our motto is. And for being in the field of energy efficiency and thermal comfort, you need to think from your heart. You need to think from your heart because there is now you can look at the world, what is going on, the change in the climate. The climate change is there. So with the words from my side, I would like to invite my chair, Sri Hitesh Vaidyaji, to say a few words, and then we can start. With the panelists one by one together. But let's start with Dr. Hitesh Vaidyaji. Sir.
Is it? Hello. Hi, good morning, everyone. Thank you for this opportunity. I also take this opportunity to thank Ministry of Housing and Urban Affairs for inviting me to chair this session. For me, IHUC, while we are celebrating the successes what we have achieved last 75 years, it is also a time to start introspecting where we have done, start learning the lessons, what we have achieved, what we have not achieved, and also to start thinking if I have to leapfrog for the future, because that's what we are here, all of us here, to shape the future. And if we have to leapfrog for that new promised land, which we are all talking about, then what that promised land will be, and what are those innovative ways of looking at it. Learning from last session where we were talking about macro picture, this session is micro picture. So we are coming down from Jaguar to Maruti 800. So I think we have to be very, very specific about what we really want to achieve when we are talking about climate smart city issues. As I said, we are all here to introspect, learn, as well as shape the future. We all also want that global commitments which our policy leaders have made, net zero, 2070. Definitely I'll not be there 2070, but some of you and young people sitting here will be there. What is the idea is, can we start the path towards that net zero and make these commitments real? And I think that is the biggest challenge with all of us. How do you make these commitments real? And that's why I think this session is very important, because it starts with the individual issues rather than broader issues. Is housing, each house, how do I make my house as a climate smart or a smart house to make that contribute to the energy efficiency and other goals? Because right now we had from all the big commitments under the SDGs or a Paris Agreement, then our INDCs, where we have committed 50% renewable energy, as well as a carbon intensity of less than 45%. But sitting as a city practitioners and city leaders, how do they convert these commitments to their action at the local level? And I think my request to all the panelists will be, we are here not to tell what we do, but give a clear guidance, give a tools, give templates, suggest some kind of a technologies, and how do we transfer this knowledge from global to local? And lastly, what type of training and capacity building is required to really take that leapfrog from where we are to the where we want to go. And I think while we are talking about climate, and I'll stop with the 3 points, while we are talking about climate smart buildings, then we need to think about the person who is going to stay in that building, and how do you broaden the dialogue with that person that he does want to have climate. And that's why I remember Terry has come up with a very good coin of word, where there is sustainable, which we all want, is affordable, or affordable is sustainable. And I think that's the debate under this discussion we want to do. While we do want to have climate smart cities or climate smart buildings, how affordable they are, and also hesitation of the consumer towards moving towards investing into this climate technologies, How does he really work on it? And lastly, I do say that, you know, how do make these technologies, which looks very nice, but how do they make them locally relevant? And that is where I think the discussion should be today. We are already running half an hour late. I leave it to moderator to manage the time. You have a tough task, but as a chair of this session, I'll try to be more of a time management and come out that, end of the day, who is our audience where we are talking about. If we can give clear guidance to the people who are at a city level, who are going to take this baton forward and make that INDC relevant, how do they relate their work to those INDCs and start showing that we are contributing to the policy dialogue, both at the national and the global level. So thank you very much, and over to you.
Thank you, sir. Thanks a lot. So we have with us a very eminent panelist over here. We have Ms. Swasini Ayerji. She is an architect, urban planner, and co-founder of the Orvilla Center for Scientific Research CSR Trust. We also have Dr. Saket Srafji. He is the founder and principal at PS Collective. Mr. Yash Suklaji, he is a professor at Sept University. Ms. Bijal Brahmabhat, ma'am, we know you since beginning, and you are basically the director of Mahila Housing Seva Trust, MST, and from online system we have Andreas Binkett, and he is basically belongs to from 200-watt energy strategies systems. So I will invite now, without taking much time of it, I will invite Swasini Ayerji to say a few words on thermal comfort and energy efficiency in buildings, and give some presentations if you have those presentations with you, just to start. Swasini. Yeah.
I have first, of course, I would like to thank Ministry of Housing and Urban Affairs for inviting us to participate in this, and specifically thanks GIZ for hosting me. I would like to just share with you a short presentation that I had made as a discussion on this session on climate smart building for affordable housing. So, I go which way? This way. Okay. You see, for many years, I worked with the building itself. How do we make adaptive comfort within the building in various interventions? But over the years, what we have realized is that with the increased distress migration from rural area and the rapid urbanization that will result from it, the demand on land, energy, water, and other primary resources to supply food, housing, urban and social infrastructure will result in increased carbon. So it's not, when we are working with just provision of housing, we are actually putting an impact and a pressure on many other areas that need to be taken into account. Then, of course, the combination of climate change, extreme climate, the urban heat island effect, which is kind of something that we need to really seriously look at, and especially in metros. Due to pollution and loss of green spaces, this increases tremendously the operative energy demand in our buildings, especially in the housing sector. And then climate-related economic losses. I live in Tamil Nadu, not far from Chennai, and I see that in the last 20 years, a regular flooding that is happening. And the other areas where it impacts in the health sector, education, infrastructure development, and other areas. So it's, when we talk about housing and climate smart housing, we are actually talking about a whole basket of issues that come with housing. So along with schemes and strategies to provide energy efficient, affordable homes, I realize, and I keep insisting in every forum, that we need systemic changes to be undertaken at the policy level at urban planning. because you cannot have a climate efficient home in an unsustainable urban environment. It is oxymoronic. So basically the silo mentality that we have in urban planning, which is a roadblock to design and development of energy efficient settlement. The second thing is the program dependence on technology driven solutions. And this is neglecting the soft investment in capacity building that is impacting the owner-driven housing that is happening, especially in second, third, and fourth-tier towns. So basically, I could end my talk here. It's saying that urban planning and land use has a huge impact on energy-efficient, affordable housing. Especially if you want to have reach a point where we can have blue-green city planning principles, which will change the urban morphology of Indian cities. We have to link land use with mobility to reduce urban air pollution and heat island effect and decentralize urban systems of resource and waste management. This has to go hand in hand, sorry, this is not meant to be going there. And of course, then energy efficient, affordable housing, more than just talking about different things that we can do to make buildings energy efficient, the three things that have a long impact all over the country would be the investment in innovation and demonstration projects. Because a lot of things are happening in academic labs and smaller areas, but these innovations are not reaching out to the people because there's very little dissemination of these things. The second is review implementation post-occupancy. If we don't learn from what we are building, we cannot constantly keep improving. We tend to stagnate and it becomes a status quo, and our solutions of today should not become the problems of tomorrow. And a linkage between design, implementation, and beneficiary. So I'm going to just run through the next ones because it basically, you see, I live in Auroville, which is an international township in making. For whatever fortunate reason, we have an institutional mechanism that actually supports integrated urban planning to promote energy efficient settlements. We invest a lot in social capacity building for active participation from the inhabitants. And we have institutional support for skill building, which is very, very important when you want to do energy efficient housing. And we invest a lot in innovation on low embodied energy building materials. And why do we do that? It's basically, when you're talking about energy efficient buildings, we're talking in two different levels. There's the embodied energy in buildings, and then there's the operational energy in buildings. If we cannot link both these things, the overall problem of provision of housing to India, and like Dr. Sridhar said, there's two different things. There's the endemic population increase within the city because of the changing in the type of family structure, but also due to migration. Provision of building materials from sourcing, manufacturing, transportation, assembly is going to impact our carbon output as much as the operational energy that is going to be used within the building if it is not built with adaptive comfort principles. So you can, I would like to say optimization, in terms of settlement planning, in terms of building planning, in terms of how we look at between land, people, and building sector itself, goes a long way in reducing the embodied energy in building sector. Reduction and replacement of certain building materials. I've been looking at the different lighthouse projects, and they're heavily dependent still on steel and cement industry. And the efficiency that has been brought in with the technologies that are used in these lighthouse projects is amazing. But we now need to go one step further and look at further replacement and reduction in steel and cement, which are high embodied energy materials. And then reduction of the carbon impact during the implementation process itself. We have visited some of these lighthouse projects. The construction management sector needs to actually have higher skill building capacity. And the last one I can't see because the gentleman is in front of me. Okay, but it's okay. I can skip that one. Solar passive building technology for reduced energy needs, operational energy needs. I don't need to go through it. These are very simple principles, but the way they impact the design of the building and the overall reduction in the operational energy of the building can go a long way in allowing us to have the resources to provide more affordable housing that is finally needed as India gets more and more urbanized. So in a way, what I'm trying to bring forward is that between urban planning, settlement planning, the social capacity building has to go hand in hand with the settlement planning aspect, which is the embodied energy and the operational energy. None of these 5 things can be segregated and tackled in silos, but with proper policy planning that is supported with programs like the PMA scheme and with the lighthouse schemes, we could build up incrementally some amount of social capacity building that allows India to urbanize without actually impacting the carbon output globally. Thank you.
Thanks a lot, Shasni ji. You have nicely elaborated the complete scenario, what is being done through the Aurovilla Institutes and the research that you have taken up. I will be putting some questions to you as well, not now, after the end. But before that, let me introduce Dr. Saket Suraf, who will be giving not his presentations, but a small talk basically on affordable housing and what he thinks about the reduction in energy demand for the affordable housing when we are talking about much more towards the building design, efficient appliances, and smart controls. What can be done more to provide this affordable, clean, and resilient energy to the residents, basically to that in the affordable housing, and also in the era of new or low carbon development, what are some of the new frontiers about reducing energy consumptions, cost, and emissions in affordable housing? That is what you are trying to explain. Thank you.
Yeah, good morning, everyone. Thanks, Vikash ji, for inviting me, and to GIZ and Ministry of Housing. So very quickly, the question posed to me was, what beyond energy efficiency for affordable housing, right? And I would pick on where Suhasini left, that energy in affordable housing should not be seen in isolation. So one direction that she took the discussion on is how do we connect energy consumption to larger settlement-wide, city-wide situation, context of land use and urban planning, right? The direction I would further take this is connecting the energy consumption in affordable housing beyond the building itself to the larger grid, okay? So the first thing that we should understand in today's age is, though we want to really optimize how much energy is being consumed in a building, in today's age, it is extremely important to understand when are we consuming that energy, right? Because energy consumed during the day and energy consumed at night has different carbon content. And with increasing renewable, that carbon content of the time of the day would change and vary a lot, okay? So my submission to the larger audience here is that yes, we have done energy efficiency for almost 20 years, trying to reduce the net energy consumed. And in current push of renewable energy, we should start looking at when is that energy being consumed. It's like, for an example, if I have to drive from here to the hotel I'm staying, if I leave now, it may take 20 minutes, but if I leave at 6 a.m., it may take only 10 minutes. Same thing is with energy. You know, energy consumed at, say, 11 a.m. coming from solar is almost zero carbon, almost. compared to the same energy if I consume at 8 p.m., which is coming from a fossil fuel thing, right? So when we want to reduce energy, we should start thinking about the carbon content of whether the energy is clean at the time we are consuming it. Is it reliable at the time we are consuming it? Is it congested at the time we are consuming it? Is it affordable at the time we are consuming it, right? Many utilities around the country are already having a time of the day tariff. So if you consume energy in a certain time of the day, you pay more, and at other times you pay less, right? So that is the first thing I would put on the table. Second is about optimization. 20 years, 30 years ago, we were optimizing building envelope on its own. Last 20 years, we are optimizing building systems, efficient lighting, efficient air conditioning. And now we are saying, no, these things need to be co-optimized. It's not first optimize the envelope, then optimize the system. We need to optimize things together. What I am putting on table is let's add grid to the whole thing. So not only optimize building and appliance together, but optimize building systems and the grid. Because the grid is also becoming increasingly variable given the renewable supply. So there are ways where we can drastically reduce the carbon content of our energy consumption and also the net consumption if we optimize the grid building and the building systems together. And then the third thing and the last thing, I'll stop here and then maybe we can continue over the discussion, is shared benefits. How do we share the benefits of reduced consumption, which is happening at societal level? So say grid level savings, building level savings, and individual household level savings, right? So how do we actually share the benefits when we are co-optimizing system across different stakeholders, right? And so I think all of this thing together is termed in the current debate and the research and projects happening globally under grid interactive affordable housing, right? And it's a system where you can do optimization across the spectrum and share the benefits among different stakeholders. I will maybe get into the details later on during the Q&A, but I'll stop here. Thank you, Vikas.
Thank you very much, Dr. Shroff. It's a grid interactive affordable housing. It's a new word, new line for the affordable housing. Let's see what's coming up. So I will invite now Dr. Yash Shukla. He is basically expert on thermal comfort and energy efficiency. He has been associated with GIZ from so many years, and under our Rachana program as well, his contribution was immense. So now I invite Yash Shukla ji for his comments on thermal comforts in affordable housing.
Thank you very much, Vikas ji. Thank you again to Ministry of Housing and Urban Affairs and GIZ for inviting me to the session. So I'm going to make a small presentation to talk a little bit about thermal comfort. So the focus of my presentation today is to talk about the work we have been doing in this domain and what are the benefits that all of you can take from this work. And the work is supported by Ministry of Housing and Urban Affairs, BMTPC and GIZ. So that's an ongoing work where I felt that sharing what is being done and what are the solutions as been spoken by the panel leader is very important in this session. So first of all, I want to say, while we talk about energy efficiency, thermal comfort is extremely important area in especially affordable housing sector. We know that our body can adjust to a small range of temperature, and beyond that, below or above it, can lead to a temporary or a permanent damage to human. And this does not only happen in outdoor conditions, but it's equally possible to happen in indoor conditions. And so we really need to look at it very closely, that we need to achieve thermal comfort in our affordable housing sector. And ultimately, the mind, state of mind defines thermal comfort, and it senses it from various senses and organs that it has to monitor the data. It goes to the mind to understand whether you are comfortable or not. The research has shown that temperature, humidity, we all know that makes us uncomfortable, but it's also important to know that the surface temperatures when you are adjacent to the walls and windows can make you very, very uncomfortable, and it has to be linked with the activity level. So a lady cooking in the kitchen may have a higher metabolic rate, and would be very important to ensure that the comfort is achieved not only when you are sleeping, but also when there are some activity happening in an affordable sector. Now, there are a few elements that I wanted to bring out in the presentation, that along with the science-based physiology aspects, there is a lot of contextual aspects in the thermal comfort. Where you grew up, what have you been exposed to, what are the factors, your gender, a lot of factors affect it. And it's very important for us to start looking at it thermal comfort more granularly, so we know what we need to achieve in our affordable houses and all buildings, and then work towards developing the solution for it. So we have been working with GIZ, with MOHUA, and different government of India agencies to look at what are the solutions that one need to think about. So we have been doing a contextual research since 10, 15 years. One of this is look at different comfort in different typologies of the houses, apartment complexes, and to develop a comfort model specific for Indian occupants. Which is very important to understand that that becomes a basis of your design, to try to understand that what is the comfort that you would need, you would want to achieve in your buildings while you do a system design or an envelope design. This has been also supplemented by years of research on a controlled environment, because there are some things you can control in the field and some things you actually have to do in the controlled environment. What I want to go into now is that the importance of looking at thermal comfort and what are the solutions that can exist. And it cannot be covered in 5 minutes, but what I would like to give is talk about is that when we look at affordable housing sector, our analysis has shown that the temperature can be reduced from 36 to 42 degrees that we see in a typical homes that has been built, a business usual homes. We can bring down to 6 to 12 degrees. Now that's a very oversimplification, but it gives a scale of information, scale of reduction that can be achieved by properly designing your houses. You can reduce this temperature, improve the comfort of occupants, productivity, and reduce the system operation times, which will ultimately lead to energy efficiency. So with help of a program that Vikasji talked about, Rachna, there is a dedicated training program that has been developed specifically to educate and create awareness of thermal comfort, adaptive thermal comfort, and the building physics behind it. And this has been going on for last 6-7 months, and a lot of training has been developed. Even the book that is you are seeing here on the handbook is part of the effort of the handbook, where all the knowledge and the contextual knowledge developed based on Indian context is produced. Now, what these courses cover, it focuses on practitioner, it focuses on code officials, and it also focuses on designers and end users who are actually trying to understand how do I achieve thermal comfort. So it focuses on one aspect of building physics. So there is something that you can see from the eyes. You can see here when a person is sending, but a lot of things are happening behind the scenes that we need to understand with different tools, different understanding of how the heat transfer mechanism works. So this course talks about, this training talks about the heat transfer basics. It also talks about various strategies that is suitable for different climatic zones. So what is suitable for hot and dry climate, warm and humid climate, and what are the spatial aspects and the material aspects that one can cover in designing of these buildings. It also talks about case studies. So this is a case study of a pool houses that was conducted in Ahmedabad, and it demonstrated an excellent use of shading because of the neighborhoods, and strategies that can be also used in the modern buildings. And one of the example that it covers, and I wanted to bring it here, especially here, is a affordable housing case study that has happened in Rajkot. So Rajkot Smart Ghar 3 has used some of these strategies and utilized this to achieve thermal comfort. They have also done the measurement to demonstrate that these strategies work. So with that, I will end the presentation, and I just wanted to give you an overview of this thing. Thank you.
Thank you very much, Yash ji. It was a nice presentations on what we have done and what Safety University has done so far on thermal comfort and all. You know, the EC Act is going to be passed soon, very soon from Parliament, where the residential building code is also put into the essential system, where it will make the complete code mandatory for residential buildings. So Equinivas Samhita code, which is part 1 and part 2, will be there, and it was developed by GIZ and Bureau of Energy Efficiency. So you will find many of these passive approaches, the active approaches, to how to get the building more comfortable, more energy efficient over there. So I would like to invite now our international guest, Mr. Andreas Binket. He's from Switzerland, and he has done lots of work on achieving this thermal comfort and energy efficiency in the building. So he's the ambassador of 200 Watt Society and president of the 200 Watt Smart Cities Associations. So now I invite Mr. Andreas Binket for his few words on thermal comfort and energy efficiency in affordable housing. Mr. Andreas Binket. He must be online, right?
Can you hear me?
Hello, Mr. Binket. Please.
Hello, can you hear me?
We can't hear you.
Can you? Can you hear me now?
Here, everything is fine, Mr. Binket. You can speak little louder,
Can you?
or
hear
you can
me
put.
now?
No, we can't hear you.
Oh,
Oh, some problem.
okay.
We can't hear. No, we can't hear.
Hello.
Mr. Binket, can I do one thing? You just we can settle down this technical glitch, and the meanwhile I'll invite other speaker to speak it out. Right?
Please do.
Now, so it's a time for Ms. Bijal Brahmbhatt to get something which is happening in the field, basically. Implementer are very less in India. One of the implementer is Ms. Bijal Brahmbhatt, who will be speaking about what she has done in the country, in the field. Thank you.
My present. All right, I'll just take the time to introduce a little about our work. So I work with the Mahila Housing Trust, and we work with poor women in the informal sector, trying to improve their housing, living, and working environments. And long back, we also started working. We have been working, in fact, more on incremental housing and upgrading slums and trying to implement technologies which are accessible, affordable, user-friendly, and at the same time aspirational, because we understood those are the 4 parameters on which poor judge technologies, and they start adopting it. But I'm not going to focus on that right now. We have done a lot of technologies for, incremental housing, and for which women have also taken complete loans to build incremental housing. What I'm going to focus on is the, affordable housing, which we have tried with the government, essentially ISSR. A lot of those elements, we co-created it with CEPT University, with the Center for, it's called CABZI, I forget the total, the full form, with Professor Rajan Raval, and a lot of the elements what Professor talked about already exist, but we have brought it down to an implementation level and taken it to the government. And the key things that we had focused on, because when we saw our poor women moving into affordable housing, was that, their energy consumption was increasing. And we said, how do we sort of reduce the heat so that, one, we do encourage them to use systems, but also reduce the heat. But the crux is that we talk of all the amount of green buildings, blah, blah, everything, but I come down to the chair's question: who is going to take it up for affordable housing? So is sustainable affordable? and is affordable, also sustainable. So we wanted to really work on that with the nitty-gritties. How do I don't know. Anyway, so can you help me do the next? It's quite a long presentation. I'll jump slides. Yeah. So I'm not going into these. Already professor said 36.5 degree to 42 degrees centigrade. So when I went to the professor at CEPT University, I said I want something which is very implementable and which doesn't increase the cost. We do keep talking of the building envelope, but I also wanted to bring it to the notice because professor was on one of the committees which was designing the energy conservation code. And at that point in time, which was 3 years back, no code existed for housing. How can we reduce the heat gain? Which has something called, you have to look at the residential envelope value, which has to be below 15 watt per meter square for all kinds of climates. It's different for different climates, of course, but for all kinds of climates. You have to look at the U value of roof, increase the natural ventilation. So openable window to floor area ratio should be such that just by deploying that, you will ensure not to increase the cost much, but ensure heat, thermal comfort. And then how do you look at daylight? So as I said, maximum value is 1.2 W per meter square for the walls, the thermal it's 15 watt per meter square for the walls, and for the roof, it's 1.2 watt per meter square. This is all very technical. And though I am an engineer, I probably wouldn't understand this, but I'm really trying to make it very simple for laymen, because one of the issue with the technologies is that they make it so difficult that probably laymen don't really understand. So I'm skipping this. So just to explain, so if you look at the RETV, which needs to be controlled, you look at the walling material and construction, look at the window to wall ratio, you look at the glass. Increasingly in places like Ahmedabad and Gujarat, which are very hot, I'm seeing it's an all glass structure, without any overhangs. You look at glasses, SHGC value, God knows what. Shades of opening and direction of wall and opening. So it's a combination of very affordable material with design orientation change. What can be done to go below 15 watt per meter square? So we also looked at the incident solar radiation based on the direction of the house. So if you are in the southwest direction, so any wall in an affordable housing which is vertical and it's on the southwest direction, it will need special attention because a lot of heat gain happens there. So any material, for example, you are applying and you don't want to apply it in entirety, it at least needs to be applied to the southwest wall. Then we looked at the openable area, as compared to a ratio of the built-up area. And so if the openable area, which is the window, area, is maintained at 10% as compared to the, floor area, then we will be probably able to control, the heat, and the natural ventilation will get enhanced. So what we did is, again, we also looked at the roof value and experimented with various materials. Now I did all these materials. I used 3 principles. They should all be available in the market. So I'm not saying that let's fund technology start. It's a different area, of course, and technology startups would have their own issue. I wanted to look at materials which are available in the market, which are not very high cost, for which I can directly give specification to the government and that they get implemented. And so we have compared, several materials, only RCC, what's the U value of the roof, then concrete, then China mosaic, then solar reflective paint, which if it is applied on the roof, probably reduces temperature of up to 3 to 9 degrees. The only thing is that it's less costly, but it has to be repainted after 4 to 5 years. So we also understood that, if you apply expanded polystyrene material, I mean, in layman language, something like a thermocol. I mean, of course, it's not fire resilient, But then, your thermal, but there could be other forms which I don't know. Then there could be a high thermal, comfort level, and it's very cheap. It's 10 to 12 rupees per square feet. And if you apply it only to the wall, which is getting the maximum radiation, or in the service, then, it will reduce the heat. Or in the service shaft, if you put a fan, which, which will create negative pressure, so that there is all along a natural ventilation. Also, the overhangs, which Professor mentioned, is very high impact and low cost value addition. Yeah, so I'm just very quickly taking you through these slides. We actually did it on one site in Ahmedabad, in ISSR. And we saw that if you look at the block A and B, which have been done through aerated autoclaved concrete, and all these principles applied, the U value, you can't see it, but it's 13.57 watt per meter square, which is below the 15 watt per meter square. And on the same site, another block the builder took, and the U value comes to 18.11 without implementing all this. It's a very long slide. We did it with changing orientation also, but you have to understand the practical issues. When you post that you should change orientation, at the same time, the FSI is not completely utilized. And therefore, if we tell any developer or even the government that, please change the orientation, probably it will not increase the cost, but no developer is going to listen to this, and neither probably the government, because we are talking of efficient use of the land. So I'm not going into these case studies. Anyone who is interested, details on how much costing has increased, etc., etc. But the point is, we have come up with a rate analysis of, and in terms of the material that we experimented, we understood that aerated autoclave concrete blocks as compared to brick, as compared to RCC, are really cost efficient and also able to bring down your U value very much. After that, the traditional brick, but RCC is the highest. And then we came up with a cost comparison. If you see, per cubic meter, traditional, before the COVID, the aerated autoclave concrete block used to increase cost by 5 to 7% with all the elements, with the overhangs, with the solar reflective paint. But after the COVID, the costs changed, and in fact, it reduced by 5 to 8%, depending on whatever adhesive you used. So we actually took this to the police department and to the climate change department, and I'm very happy to let you know that the climate change department, the police department actually, have now included it in their police low-cost housing, just because we give very clear rate of analysis and specifications. With the costing, they could just pick it up and use it there. So, thanks.
Thank you, Ms. Bizel. It was nice hearing that the work that GIZ and Bureau of Financier has done on Equinivas Samhita was now getting the benefits out of it and implementing is easiest mode of systems. I have my two colleagues over here, Mr. Abdullah Nishar Siddiqui and Govinda Samani. Both are have basically given lots of input on getting this equation RATV done. So a lot of applause for both of them. Now I will again come back to Andreas Blinkert if he's available now with his sound. Please.
Good morning, everybody. Can you hear me?
Yes, now I can. Now we can hear you. No problem. Yeah.
Okay, wonderful. Can you also see my presentation?
Yes, we can. Please go
Okay.
ahead.
Well, good morning again, ladies and gentlemen. I am very pleased that it works now, and I'm very flattered to have been invited to this conference. And especially, hello, Hitesh, you've asked us for templates. And that's what I'd like to do with my presentation on 2000 watt smart cities. The idea of 2000 watt smart cities comes from the simple fact that we have to get to net zero in Europe by 2050, in China by 2060, and in India by 2070. Now, the bad news is that nobody knows how to do that. I don't either. The good news is when the Americans wanted to go on the moon, they announced it and they didn't know how to do it either. So they did it in the end, and we will reach that goal, net zero. I am convinced of that. However, right now we don't know how to do it, and therefore what we can do, instead of doing nothing, we can do the best we can, and that is to go down to 2000 watt. We all are now using in urban environments around the globe somewhere around 10,000 watt or 10,000 kilos of CO2 emission. And we have to come down to 2000. And we've done that in Switzerland. This is the first project where we try to make a whole precinct, or call it a neighborhood, or call it a community, carbon neutral. This area here, Green City in Zurich, is running without emitting any CO2 whatsoever. It's carbon neutral. And what started with Green City in Zurich soon became a standard in Zurich and is becoming a standard throughout Switzerland, making Switzerland a carbon neutral smart city by 2035. By now, we have already certified 46, I think it is today, of such communities where people live comfortably, affordably, and happily. So why can we not do a similar thing in India? We've tried in 2018. You see here, the lady is the president at the time of Switzerland, with Minister of Maharashtra, Mr. Fadnavis, who was the first one to realize that this concept of building smarter cities taken from Switzerland could be taken to Maharashtra. And if it can be taken to Maharashtra, it can be taken to any state in India. The first thing we did is we looked at the building codes and we came up with design guidelines for India for the different climate zones that make the building design more functional and more efficient. But now, what is a 2000 watt smart city? A 2000 watt smart city consists of a grid. Now we're talking again about the grid, like Saket just did. The grid of cities, the grid of communities, of independent and well-connected smaller units. These units need to have certain qualities. Density, inclusivity, and diversity is one of them. Independence and connectivity is a second one. And of course, low carbon construction, just like what Bijal told us just a minute ago. This is very, very important. Here's the smart grid. We start with a building that operates carbon-free, and it's possible to do that both in India and Switzerland and around the globe. Many of these buildings together form a community which has to be a smart community, has to use the minimal of technology that is necessary to make it smart. And several ones of those communities together form a town, and several of these towns together form the city, just like the city of Switzerland or the city of New Delhi or any other place. We've done that, well, I shouldn't say done that, that's too much. We are trying to do that in 3 places in Pune already, where we have designed master plans for such townships or such communities. This is an all-inclusive and affordable community. You may think that me coming from Switzerland, being a rich country, everything is very expensive. Well, Switzerland is expensive. It has become expensive. But Switzerland only 200 years ago was a poor farmer's country. And we still are farmers. So the city of the future is going to be a 2000 watt smart city. You can also find that on a TEDx talk. If you look at the City of the Future with my name, you will find more details on it than I can explain in those 5 minutes I still have. We are starting with 3 pillars: density, connectivity, and mixed use, as I mentioned before, and we made 6 areas that we are focusing our controlling eye, especially governance, buildings, centrality, energy, mobility, and smart food production and tech centers. We've come up with a model community on 1 square kilometer, if it is greenfield, but it can also be brownfield. Now, mixed use is something that I'd like to focus on a little bit. Mixed use also means social mix. Mixed use means we need to have housing and working, schools and daycares, communal rooms and old people's areas, doctors and shopping. All of that within this 1 square kilometer. That makes it possible to make it affordable. And by the way, in these towns that I mentioned and that I showed you the 46 examples of, we have the rule that 30% of such communities must be habitation that is dedicated to lower income groups. So whilst the richer areas may be the fancier ones, they pay for the lower income groups. And we are training this also. Education, we've heard that earlier, is essential. Education here, I just got that yesterday in a paper. This is a course given for a social mix in these communities. And it starts 16th of November. And if your German is good enough, you're welcome to join. I will definitely go. Here you see how such a square kilometer is being built up. First of all, what we do is we dedicate 50% of it to become green or stay green area. We build roads, we build building lots, we build planting lots, we plant trees. We even make a forest for water and cooling purposes, green fields with solar farms, and only at the very end, we let investors build the town. So in short, this template that Hitesh has asked us to come up with, this template is a multiple of 1 square kilometers of land with an FAR of at least 1, which is good enough to bring 10,000 residents and 10,000 people who work there. It will be independent in supplies, water will be independent from the grid, and electricity will be independent from the grid. And of course, it's connected. So here is this typical template town. What it does is it is what we call a 15-minute city. It is walkable. It is scalable. You can add several ones to it and make it bigger. It is comfortable, healthy, safe, bankable, very important, because the best ideas don't help us unless they are bankable and will be built. Only that is sustainable.
Mr. Andreas,
Yep.
Mr. Andreas,
Yep.
Can we make it quick? We have a very less time now.
Yeah.
Please be quick. Yeah.
Okay. I will quickly go through the design topics here: cross ventilation, shading windows, cooling by taps, solar pergola, urban gardening, rainwater harvesting, and fluid waste. This is what we do in these buildings. You see a couple of examples here. Here are a few that are built in Switzerland. A schoolhouse with the same system. And of course, all of that needs to have a label so that we can control whether what we are proposing really works. Here you see the balance scorecard. The label has been given the first time to Symbiosis University in Pune, and we're very happy to know that even a brownfield project can be labeled 2000 watt. So that's my last slide. The Indian governments can expect a few things from 2000 watt template, if you want. You see them here. It provides implementation framework, and we can control that it fulfills the promised net zero agreements that Prime Minister Modi mentioned on COP27. It allows the government to control and monitor the progress. It can show success in action and can tell that the decarbonization in India is getting towards sustainable development goals of the UN. And the Swiss tested certification process helps these developing cities to get funding. The collaboration, of course, between our two governments helps us to have better exchange of clean tech, high tech, and green financing. So all of this together is what I can offer, like to offer to India, to the communities, to become more attractive, more livable, more efficient, and affordable. Thank you very much.
Thank you, Mr. Andreas. It was enlightening to see all this work, what you've done over there in Switzerland. And naturally, Indian government will be here and implementing lots of things which you have suggested. So now I invite Harsha. Harsha is leading RMI's India's work on carbon-free building, focusing on developing cost-effective decarbonization solutions for the built environment. Harsha, please, you have to be very quick in your responses.
Yes, sir. Like MS Dhoni, I'll keep it short in the last over. Thank you. Good afternoon, everyone. Thank you to IUHC and Vikas Ji for extending the invite. To the first point that the speakers made about is affordable sustainable or is sustainability affordable? For many people, thermal comfort is transitioning from being perceived as a luxury to more of a vital role for their health, prosperity, and productivity as well. So in this juncture, when we are looking at thermal comfort and energy efficiency, at the current, the appliance penetration is about, the room air conditioning penetration is about 8%. And with the rising temperatures and with the growing middle class, this is only going to increase. So thermal comfort, besides being a cooling problem, is also going to be a challenge to the grids, as the speakers have mentioned. And with all the passive design measures, we have several case studies which say that up to 25% reduction in energy use is possible. As the speakers before have highlighted, and we are working along with NIUA in publishing a report on a whole systems approach to decarbonizing the building sector. As the speakers before have highlighted, we have to look at first reducing the energy use. We use a term called as negawatt. Not the megawatt, but negawatt, the energy which you do not consume. This is very much in line with the comments our Honorable Prime Minister made on lifestyle for sustainability. The energy that you do not consume is actually a saving over there. So first you reduce it, then you serve it more efficiently. It's not just when you're serving, it's not about maintaining the air temperature, but for thermal comfort, it's a lot to do with the air movement and the air velocity in itself, which can definitely be achieved when you look at other solutions like BLDC fans and super efficient equipment over there. And the third thing is with respect to optimizing this energy use, both with the time and with the supply of clean energy, which you can link it with grid interactive buildings. And about 250 ancillary industries are associated with the building sector. So building sector has a huge responsibility in driving down the carbon intensity and contributing to the NDCs which are committed at COP26. Thank you very much.
Very quick, very fast. Thank you very much, Harsha. We have here a guest, Dr. Ashok Kumar. He's from CBRA basically, and he was instrumental in developing all these codes and rules basically. So I invite him for a few words on thermal comfort and energy efficiency in residential buildings, sir.
Thank you, Vikas, for giving me this opportunity. It's wonderful to talk about, affordability and sustainability. And I was surprised that, most of the presenters, panelists, didn't talk about the quantification. When we say that, anything which is to be, reduced, we are talking about thermal comfort reduction. We have to quantify. We have to quantify everything. Suppose we are talking about building physics parameters, passive design measures. What is the impact of, say, shading devices, orientation. So all that, it is very, very essential to quantify. So we at CBRI has done a lot of work on quantification and then measuring it and validating it. So all these measures, these passive design measures or using building physics principles, they contribute to the tune of about a reduction in the overall thermal comfort load by about 50%. So that means that the other measures where we are talking about building system design, it is only left with 50%, right? This is number one. Number two, madam talks about, there are no codes available before ECVC 2017. Incorrect. Let me draw your attention of the Handbook on Functional Requirements of Buildings, SP 41, which is 1987, which is the Bible of, building science and technology that we all studied, we have grown up. And all those, National Building Code, 1983, 2005, 2016, they also incorporate all those measures, and affordability is a part of that particular document where we talk about low-cost housing. IS 8888 is one such document which talks about, minimum requirements of housing for economically weaker sections and the low-income housing. So I think there is a need to sensitize people. There's a need to impart training, capacity building on all these measures which are available in the public domain, and to utilize in public housing or affordable housing projects. Thank you.
Thank you, sir. Thank you very much for your very valuable input, sir. And we know about all the standards. SP41 was the basically grant for this complete exercise what we have done so far. Now I will pose one general question to all of the speakers, eminent panelists over here. One question, sir, for another 2 minutes for each speaker. 2 minutes, sir. Yeah. I will get few minutes from you, sir. Okay. So the question is very simple.
I think can we go directly a question to the
audience
fine. Rather than individually asking each one of that. Otherwise, it will be a we are cutting on their time. Yeah.
Sure.
Thank you very much. Myself, P.N. Oja from National Council for Cement and Building Materials, Ballabgarh. So as Dr. Kumar was saying, it is must to quantify the demand side of things, demand side of energy. Whenever you are designing the net zero building or net zero community or net zero city, net zero carbon city, then it is must to design. And how it will be designed? When it will quantify. Then how you will quantify? You will have the prescription of in which climatic zone you are adopting which kind of measures, and because not the same measures or cavity walls or thick walls or light walls will work for every climatic zone. So you will have to classify the measures in the each climatic zone, and you will have to, like we are doing for the earthquake, we are doing for the durability design of concrete in any zone of India. The zone of India is being divided. You will have to revisit to the climatic zone of India as per the thermal comfort first. Then you will have to provide the guidelines how it should be designed and what can be the possible measures. And if this is the possible measures, this is the quantified value for the demand side of energy. Then if you are taking the measures to supply it by renewable sources, then you will have to quantify the supply side of energy, and then you will have to minimize the deficit between the demand side and supply side. And when you will come to the zero level, then it will be called the net zero carbon building or net zero community or net zero planning. So all of you who are working in this field, you will have to see this totality. Providing a particular case study will not serve the purpose, because same prescription will not work. Same prescription given by the doctor will not work for everyone, and it will kill the patient. Okay? So we will have to have a systematic approach, and we need to revise the standard. We need to revise the guidelines. Of course, SP 41 is a Bible, but we will have to see the energy demand and energy supply in a new environment, in a new way. Thank you very much.
Thank you, Judge Saab. Any answer from, yes, sir.
Question? Yeah, Sejal.
Thank you very much. I'm Sejal Patel. I'm a professor at CEPT University. I think these are very important deliberations and some very, very interesting research and ideas have already been discussed. My question goes back to, the basics that let us understand the full gamut of affordable housing in India. And it goes from the smallest homeless person to units which are built by the markets and understood in the policy as affordable housing, which are in the price range of 45 lakhs. So a big gamut of housing typologies. So who are we talking about, or who are we addressing when we talk about issues around thermal comfort, energy efficiency, or even net zero when we talk about affordable housing? If we again look at the total housing demand and supply in affordable housing, the biggest supplier is self-built housing. And self-built housing constitutes anything, in cities from 50 to 80% of the total supply. And in that, again, a major component is self-built housing built by poor. And I think there some of the experiments which are, and the practices which have been shown are very important. Because for that person, net zero is not important. For them, sustainability is not an important, but it is a thermal comfort, or I would rather say climatic comfort, which is important. And I think for them, we need to have answers. What can they do it yourself? Do we have anything about do it yourself where they can build for themselves with some guidance and help? So I think that is my one point. And my second point is quite often this entire, a debate and the policy instruments which are there, ranging from thermal comfort to energy efficiency to green buildings, and again incentive. Green building is a market approach, but incentives given to green buildings, and then macro level plans, climate plans at the state and the local level. These are about eventually, climate resilience. And sustainability often does not sit well with the resilient indicators and parameters. So even when we talk about all of these, quite often, for instance, if we have SRI paints, they may be also, they may lead to thermal comfort, but quite often they also have VOC, which will contribute to the the GHG emissions. So how are these contradictions also addressed, I think? And eventually also the contradictions between some of the indicators of climate resilience and sustainability, how are these addressed? Along with its intersection with the wide gamut of affordable housing. I think that's the complexity in which we are working and the landscape within which we are working. So.
Thank you, Sejal. Too many questions, but I think very valid one. I really want some of them if quickly we can.
Sir, one last question.
Yeah. One question.
There's one more.
We'll take two questions and then, yeah.
I'm Colonel Pawan Pandey.
But let's make your question short.
Okay. I'm Colonel Pawan Pandey from MES, and my question is more close to what Ms. Sejal has said. We are thinking, firstly, we have not defined which group we are targeting. So first thing is, are we focusing on the houses which is already constructed or the one which is going to come up? There are houses already constructed about 24 crores. If you can reduce just 1 degree in each house, imagine the kind of saving in energy you can have it. So I think the first focus should be on the one which is already constructed. The second thing, what I'm just trying to understand, because I'm not very good in this field, I have heard somewhere that the tall buildings and the houses in a cluster can be created in such a manner that they create tunnel effect and improve the airflow. And that is quite much possible, especially in the corporate big complexes where the energy level can come down. So are we doing something on that cluster level also, or we are just stopping at the dwelling unit levels? Thank you.
Thank you, sir.
I'll ask panelists to start responding, otherwise, yeah.
Sir, this is Amol Desai from Supreme. I am also a core member of India Insulation Forum. We have been working on this concept. Now, the two things of thermal comfort and energy efficiency in buildings, both the things can be achieved by using insulation, by putting an insulation envelope over the building. Okay, the code says in a prescriptive manner, But our experience is, as long as you don't make it mandatory, people will not enforce it. The architects refrain from using it because, I mean, they might recommend. The builders refrain because the cost increases, not looking at it from the long-term point of view. So the thing is, who will build the cat? Unless and until it is made mandatory, nobody will use it. It's just like helmets. It's for the safety of the riders, but the government has to make it compulsory. So if it has to be for the comfort of the inhabitants, government has to look for the mandatory of insulation in the buildings. And as madam has shown, the easiest way of putting it on the outside, we have seen, we give the training, we have experiencing 15 to 20 degrees difference in the drop in temperature. Okay, so that's the comfort level we can see. Thank you.
Thank you. I'll quickly ask some of the panelists want to respond because they have very, very particular question and maybe all of you want to respond, but maybe you can start quickly.
I will stand and speak because I can't see half of you. Yeah. So I would choose to respond to Sejal's question. I think that's a very relevant question. Sometimes we forget, the energy consumption in affordable housing may be like 5% of the bill I pay every month. Okay. And out of that 5%, if I save them 10%, right, how much is the net saving at a household level? And for that, how much extra money they would be willing to pay, right? So in the whole list of priorities for affordable housing, the energy bill comes way down, right? Now, so we need solutions which can scale up very fast without increasing the cost to the resident in terms of capital cost or operating cost. And one thing that attracted me to the grid interactive housing is that it allows to reduce the operating cost, the energy cost of household very drastically via partnership. And I'll give you a simple example, for a grid to supply you energy at peak hours cost much more than to supply you at non-peak hours, right? And so if the grid gets into a partnership with the building, say an affordable housing, and says, please don't pump water from 10 to 11 when I am stressed. Can you pump water when I tell you that, look, we have surplus renewable in our system. So I tell you pump from 9 to 10 or maybe pump from 11 to 12. And if you do that, we will give you a 10% rebate, right? So we are not doing any capital expenditure. We are not doing any fancy design. We are not changing the market. All we are doing is a simple communication between the building and the grid that is transactional in nature. Another example is blackouts, right? If there's an extra demand, the whole neighborhood kind of goes into a blackout. What if the grid tells the building, look, we are foreseeing a blackout. If you switch off non-essential loads, maybe all of you would have a fan and a tube light, right? And if you don't switch off, then your fan and tube light would be gone along with your refrigerator, right? So again, we are not incurring any capital cost. It's a direct communication and the shared benefit, the grid will benefit a lot and pass some of that benefit to the affordable housing in terms of tariff rebates, which it is already doing to industries, right? Industry has a time of the day tariff. So it's extending the same idea to affordable housing. Let's stop here, thanks.
Any other want to respond? Yeah.
I would like to, I don't know if this is working. Yeah. All the four persons actually commented, not questioned, to start with, on specific areas where they felt emphasis has to be given. What I would like to respond to the suggestions is that when we are talking about energy efficient, affordable housing, I would like to look at the macro level of the word affordable: political, environmental, social, and economic. We are looking often only at the economic level of affordability, but at a macro level, can this country politically and socially afford to house the people who need housing? This means we need to rethink in terms of strategy and policy, which comes back to what Sir said, is that we need to have diversity in terms of our regulatory mechanism and in terms of our ability to respond in terms of continuity. That means it's not just in terms of adaptive climate comfort, but skill, building materials, vernacular traditions, And over and above, one more thing which we need to look at is what kind of society do we want to build? If we only work with the hardware, which is the building, and keep responding to the challenges that are only in the building sector and not respond to the challenge of making social change, all our regulatory mechanisms fail when it comes to implementation. Because let's be honest, I know as an Indian, my talent lies in how to work around regulations and not how to work with regulations. So social change has to go hand in hand with technology and economic interventions.
Yeah, thank you. I completely agree with the concept that there needs to be a lot of awareness building that has to be done. And to your question on creating the market and making it mandates, I think it has to be driven a lot from the market. There should be a pull from the market side. Such as one of the things we are currently doing is we have launched the Lodha Net Zero Urban Accelerator very recently. One of the goal of that is development decoupled from carbon. How can we provide passive thermal comfort to 1 million people using all the strategies that you have mentioned at cluster level? Does it give natural ventilation? So we're testing a host of strategies which can all do this. And to Dr. Saket's point on how can you share the benefits that you're coming out of it? If you're only looking at your electricity bill, it might not be long. It might not be more. But if you look at the prices on IEX, which have increased close to 10.5 rupees per kilowatt hour, which was recently done. So when you're looking at all those things, at the DISCOM level, you'll be having a lot of benefits, and how can we share that benefits down to the consumer, and how can you make the residential users an active part of this ecosystem? Because the residential floor space is almost set to double within the next 2 decades. So you can't ignore the customer anymore, and you have to make him an active role so that you don't have idle capacities when you expand your grid. Thank you.
Thank you, Harsha. I think it's a time to sum up, and I don't want to stand between lunch and the session. So I just want to quickly sum up. I think it's very difficult to sum up different perspective. But what I understood a little bit, sorry, again, I am also not an expert on this subject, but what I understood as a layman, I particularly think that if municipal services and housing has to be energy efficient, then we definitely need what our Prime Minister, Honorable Prime Minister called lifestyle for environment, which means we need to nudge individuals, we need to nudge institutions, we need to have a systematic changes. Our governance framework, somebody talked about, which has to be really, that was not the mandate as of now, even though delivery is there, but how do you make it, what type of manpower, what type of skills you require at the urban local body levels. And I definitely feel, and I think somebody has said, while capital expenditure is good, let's make operation and maintenance also as a sexy subject, because that's not sexy, and that has to be brought in much more picture. But I will sum up with 2 sentences, and while I was listening, one thing which was going on in my mind was the prayer which I do every morning, which it says, Bal Buddhi Vidya Dehu Harahu Kalesh Vikar. If cities' problems have to be addressed, then they have to be empowered, they have to give the knowledge, and then action through a demonstrative project. Unless these 3 things come up, your problem of cities cannot be achieved. So we have to focus much more of empowering our urban local bodies through this knowledge. We have to show them demonstrative projects. So they start, the language of climate has to become the language of cities. If that does not become a language of cities, we will be having these presentations which will be more English. But I think we have to take the perspective, look at from their lenses what they are looking for, and then say how we can do. And somebody talked about what is the demand and what is the supply. We as a professionals have to become up that bridge between them, demand and supply, and that is what the takeaway for me is. So thank you very much.
I would go with vote of thanks now, and somebody is also coming with the summing up procedures. Do you have something over there with you? Okay. Please come up to the stage. In the front, the photographs. Go to the well, sir. So they are the real ambassador, basically. They are the real ambassador, and we need the ownership, and that is what we are doing. These students, they are the future of India, and they are coming up with nice presentations, what we have discussed today. It was very nice to see their generosity on the topics that we have now. So it is basically an ownership that has to be taken by us. We are all living in a house, and we know what is house and all about. So it is very difficult to work for a thermal comfort or energy efficiency in a house because everybody knew about their problems and their energy. I will sum up with only one thing, which is again the sentence from Sir about the language of climate professional should be a language of the cities, the stakeholders, so that everybody will be on the same line, same platform to get the bridge done through thermal comfort and energy efficiency. Thank you very much for the spectators, for the audiences, and thank you panelists for your nice and great views on thermal comfort and energy efficiency. Thank you very much, sir. We can have a photograph, sir, and before that, but a token of sir, moment for all of us. Please come.